Okay, you may have noticed I have a new microphone on. We're trying audio improvement for your brothers and sisters in YouTube land, so we will see how that works. Would you like to know the secret to picking stocks? How many of you said, I'm going to take a finance class. Hopefully he'll teach us how to pick stocks. You weren't that guy? Good. Because you shouldn't. You should not pick stocks. I know it's breaking Yaro's heart because this is what he wants to convince people, that he can do better than them so they'll pay him money. Wrong. Now, here's why. How many people do you think are out there that have access to better information than you and have access to faster computers than you, right? All sorts of people with advantages that you don't have. So at this point, it doesn't make any sense for you to go out there and think that you can spot some stock that's just going to go through the roof. Hey, you might, but it would purely be luck, kind of like winning at a slot machine, right? In fact, when you talk to your friends, which other stock trades will they tell you about? Will they tell you about where they lost their ass? No, they always tell you, oh yeah, I made 300% on that stock. I had a professor at Kent State University, and he was standing up front of the class, and he was telling us about these amazing stock trades that he'd made. And I raised my hand, and I said, sir, if you are making so much money trading stocks, why are you here on a Friday night teaching us? And he said, I didn't tell you about the bad ones. So how can we avoid the bad ones? Hold a diversified portfolio. How can we hold a diversified portfolio? Buy the S&P 500 ETF, SPY. And I've got a new discussion up about where basically Warren Buffett tells you the same thing. Now you say, wait a minute, Warren Buffett's a world-class stock picker. Yeah, Warren's got some resources that you don't have. Does that make sense? Okay. So last time we finished up here. And remember, our assumption so far with this long-term financial planning is that we are at full capacity. But what if we weren't at full capacity? It means that we could grow some before we have to add assets. And that to reach this new level of sales, of 20% greater, maybe we won't have to add 20% assets. We'll have to add something less because we were not already at full capacity. So the sales we can think of as being our fraction of full capacity used times full capacity. We are now being told we're running at 90% full capacity. So if I want to calculate full capacity, what I have to do is take 1,000 and divide by 0.90, and that tells me my full capacity is 1,111.11111. It just goes on forever. Okay, now we're going to try to find out how that full capacity compares to our new level of sales. And I'm going to tell you right now, there's a mathematical error in the next bullet. I'll point it out. If I wanted to figure out that percentage increase over the current, what I would do is take 1,200, our new sales level, subtract full capacity, and then divide by full capacity. And that would give me 8% or 0.08. If I just take 1,200 and divide by full capacity, it gives me 1.08. And if you do the algebra out, you can see why that works. So that is not necessarily correct. You could scratch out that 1 and it would be correct. So that's an 8% increase. So how much do we need in assets? Well, if you remember last time, we had 500 in assets. And if we take 500 times 1.08 to increase that by 8%, that brings us up to 540. So we really only need to add 40 in new assets to be able to do this, because then our new sales level would match full capacity. Now this sounds all sorts of fun, and the remaining steps will be the same as before. Now that we have this new asset level, we can go ahead and figure out how much in debt, how much in equity, that sort of thing. But I want to tell you that probably we don't actually want to be at full capacity. So What happens if you are operating at full capacity and you have a mistake? Anybody here ever make mistakes? Yeah, we all do, right? Because we're human. Even AI makes mistakes. And when you screw something up, what do you have to do? You got to fix it. You got to redo it. Sometimes you just wad it up and start totally over again, right? And so when you do that, if you're at full capacity, now you are running behind. You see that? If you have to stop and redo something, now you're running behind. Now, I have a choice at that point. I can either be late with all of my promises for the rest of all time, or I can just tell the next person to get lost, and then everyone else is on time. Neither one of those things are good for long-term good customer relations. And so one of the things that I always did when I was running an operation is to keep some slack capacity. I knew my guys were going to screw up. I knew we were going to have to remake stuff. So I always wanted to keep slack capacity. I tried to run around 80%. Also, if you have a machine and that machine has to be running 24/7 in order for everything to be on time, what happens when the machine breaks down? You're out of luck. Once more, everything is going to be late, or you have to really disappoint one customer. But here was my favorite one, and it was taking on surprise orders. So the valves I was making, they averaged around $100,000 a piece. And keep in mind, this is 1997, so that's a whole lot more than that now. The valves, so where were they being put into the earth? Offshore. They were being put in the earth offshore. And so there had to be a rig there, a drilling rig. Drilling rigs at the time, just the rental alone, cost $250,000 a day. Plus there's the feeding and watering of the crew, the supplies, there's all sorts of stuff that you had to pay for while that rig was on site. If someone was stupid enough to start on a well and not order their valve in advance or far enough in advance, then they would be running late and sitting there clocking $250,000 a day while they waited for the valve. Do you think there's a possibility that if I could get the valve to them more quickly, that they would be willing to pay more? Oh yeah. And so if I can save them one day, it saves them $250,000. And so if by taking this rush order, I'm only saving them one day, let's say I split that between us and them, and I ask $225,000 for the valve. By the way, I'm already charging more than 100% markup, right? But are they happy to get it? Oh yeah, they're still $125,000 better off. What if I can save them even more time? I can charge them even more. So I always like to have some spare capacity, so when some really desperately hard up company man called me, I could basically crank out a valve fast enough to save them some rig time and capture part of that value. Does that make sense? Do you think it's immoral to raise prices when you know someone's in dire need? No, we're sharing the value of my effort on their behalf, right? That's not a big, so it's just like when you order stuff, do you pay more for faster shipping? Yeah. Do you choose to pay more for faster shipping? Yeah. And if you don't want faster shipping, what do you do? Standard. Yeah, you go standard. And then you wait and you wait and you wait, right? Okay. So previously, we were assuming that we were at full capacity and we wanted to stay at full capacity. I'm telling you that whatever your capacity is at, if you use the techniques I've already shown to you, the numbers that you get will result in you ending up at the same percentage of full capacity. If I was at 80% full capacity to begin with, and I use the techniques I've already showed you, then you'll be at 80% capacity after the new growth. And that's where I would stay. I tried to stay around 80% capacity. I also tried to work my guys 40 hours a week. And then 50 hours a week, 50 hours a week. And here's why. I could always bump up. They were willing to work more because of time and a half, right? But if business slowed down, what could I do? I could take them back down to 40 hours a week. Did I have to lay anybody off? No. So these are things to think about. It might not be saving the most money today by having your people work a little overtime, but it sure keeps you from having to lay off when everything goes straight to hell. By the way, does every industry have cycles? Yeah, everything has ups and downs. We'll take O'Reilly Auto Parts, for example. When everybody's buying and driving new cars, how's the business at O'Reilly? Not good, right? I mean, we're still changing our oil and stuff like that, but we don't need necessarily a new brake master cylinder, that sort of stuff. Now, what happened when the financial crisis hit? Suddenly, everybody learns to be a shade tree mechanic because, number one, I can't afford a new car. Number two, after talking to the auto mechanic, I can't afford them. So where do I go? I go down to O'Reilly and I get my auto parts. Everything has cycles. Questions? Okay, so here is our summary. What do? The first thing is to forecast the sales growth. Remember that sales growth comes out of the strategic planning process. We're going to note our capacity utilization and constraints like the dividend payout policy and the capital structure policy. Remember, dividend payout policy is trying to decide how much of that net income we're going to pay out as dividends and how much we're going to retain. Why is that important? What does that retained earnings represent? What are we going to use that for in our long-term financial plan? I'll get you started. It's internal equity. It's internal equity, right? So that's why that's important. Now, what about the capital structure? Well, I've got to figure out how much of this new money that I needs to be from issuing debt, and how much of it needs to come from issuing stock. So that's where the capital structure constraints come into play. Then we're going to find the percentage increase in assets needed to support the new sales level. Now here I say consider capacity utilization. We only have to do that if they tell us we are less than full capacity and we want to be at full capacity. Otherwise, what we're going to do is work just the same way as we did in examples 1 through 4, and we will end up at exactly the same percentage of capacity utilization that we started with. Okay. We're going to find external financing needed by subtracting our old debt and our old equity. So in our examples, that was $250 and $250. And the new ARE. What does ARE stand for? Very good, addition retained earnings. You deserve for just speaking up. Whoa, very good. Okay, addition to retained earnings. So we've got our old debt, we've got our old equity, we've got our new internal equity. Anything over and above that we need has to be external financing needed. Now we are going to then use our capital structure constraints to tell us how much of that external financing needed is going to come from external equity or new issues of stock, and how much is going to come from borrowing. So that is the summary. Questions? Now, have you guys noticed, if you've already worked the exam calculation practices, how many external financing problems did you see? Oh, you guys need to look. Okay, now we're on to external financing needed and growth. We're going to talk about 2 growth rates. And the first one we're going to talk about is the internal growth rate. This is also known as IGR. And that tells us how fast the company can grow on internal equity alone. And so we make our net income, we pay out our dividends, everything else that's left is addition to retained earnings. We use that money to grow the assets of the firm, and that is what we're talking about here. How fast can I grow just on that internal equity? The sustainable growth rate, also called SGR, is the rate at which I can grow on internal equity alone and enough new debt to keep the debt-to-equity ratio the same. Enough new debt to keep the debt-to-equity ratio the same. Okay, so let's do an example here. If I've got $1 worth of addition to retained earnings in the IGR scenario, I can grow my assets by $1. But if I am in the SGR scenario and I've got a debt-to-equity ratio of 1, that means half equity, half debt. For every dollar of addition to retained earnings, not only can I grow my assets by that dollar of equity, I can also borrow another dollar because that keeps my debt-to-equity ratio the same. So 1 plus 1 is how much? I know you guys can get this. 2, very good. So we can grow twice as fast in that scenario with using SGR and IGR. Now, sometimes students say, well, wait a minute, that means SGR is the fastest a company can possibly grow. Wrong. 2 things we could do. Number 1, we could release that constraint to the capital structure and go out there and borrow a whole lot of money, right? But that's going to mess up our capital structure. The second thing we could do is borrow money and then issue enough additional stock to stay at our current capital structure. When should you do that? If the company is growing like crazy, the opportunity is huge. So when we see a company do an IPO, that's what we see them doing, is they're issuing a lot of external equity because they know that opportunity is just so big. Typically, I would prefer to grow at the SGR rate, or if my forecasted sales rate was lower than that, I would grow at less than that. Because after all, I don't want to grow my assets any faster than that increase in sales. On average, I should say, because we know it's not perfect. Questions? Okay, so here is the formula for the internal growth rate. And it starts on top with ROA. What does ROA stand for? Return on assets. And you see ROA also there in the bottom. And you notice it's multiplied by something called B. B has 2 different names. One of them is the plowback ratio. The other is the retention ratio. And what is B? B is just equal to the addition to retained earnings divided by net income. That's all it is, nothing special. Now the fun thing is, this is related to the dividend payout ratio. How is it related to the dividend payout ratio? Well, it's also 1 minus dividends divided by net income. Because we know those 2 things have to add together to 1. We talked about this last time. Now what does that mean? It means when you get one of these problems, you need to read. By the way, most common error students make on finance exams, it's not mathematics, it's in reading. You need to read and see what I've given you. If I've given you the plowback ratio, plug it in, that's B. What if I give you the dividend payout ratio? What do you have to do? Say again?
Find the retention ratio.
Yeah, and how do I do that?
It's 1 minus 2.
Yeah, it's 1 minus. Now, if you're lucky enough that I give you a dividend payout ratio of 50%, and you're not smart enough to do 1 minus, you still come out okay. In every other conceivable scenario, you will be wrong. Okay, so if I were you, how would I do this on my calculator? First thing I would do is figure out what B is. And then multiply that by ROA. And then I would hit, do you see the button that says STO? S-T-O? That's short for store. You're going to say store 1. That's going to store it in location 1. And why are we going to do that? Because this thing shows up twice, right? This thing shows up twice. And so then I'm going to say divide by, open parenthesis, the one that looks like this, 1 minus recall 1. You see it's the same thing down there on the bottom. Close parentheses equals. And that's how I would go about doing this on my calculator. By the way, keep all intermediate steps in your calculator. Don't write that crap down. So here's what happens. You come up with something that has 7 decimal places. Are you going to write all 7 down? No. You're going to write down 4, maybe. Are you necessarily going to always write them down correctly? No. And then you're going to have to put that back into your calculator. You're definitely not getting all 7 digits back in there. You might not even be typing in the numbers correctly. So there's 2 opportunities for a screw up here, plus you've lost some information. Keep everything in your calculator. The only thing you should be rounding off is your final answer. If you go through the exam practices, when you go through them, try very hard not to write down any of the intermediate steps. The only thing that I will do is I will make a little note on the formula. Above the formula, I will write a little number 1 and circle it. That means I've stored that in location 1. So I would draw a little bracket underneath ROA times B there, and I put a little number 1 and I'd circle it. And that's to remember where I hid that number, because sometimes we hide more than one number. Any questions?
We get a page of notes handwritten.
Yep.
We get scratch paper.
2 pages of scratch paper. Yeah, and you got to show them all to the camera before you start, so I know you don't have 3 pages of notes. Questions? Okay.
So I have a question about the retention ratio.
Okay.
Is that the formula that's net income minus dividends divided by net income?
Yeah, so what do I get when I take net income minus dividends?
Sorry?
What is net income minus dividends?
Retention ratio?
It's no. So just net income minus dividends is addition to retained earnings. And if I take addition to retained earnings and divide by net income, that gives me the retention ratio.
I see, yeah.
Cool. Other questions?
So you don't recommend using double brackets to separate it, or would that be fine?
Can if you like. The trick is to remember this, folks.
I feel like I'm going to forget this stuff.
So what you need to do is figure out what works best for you, right? But if I have 2 of these, how many of these do I need? 2, right? So the way I went through and did it, you only
Can you
need
just re-explain
1.
just so that I can write it down?
Oh, to give you okay. So first thing I'm going to do is multiply ROA times B. That's step number 1. Step number 2. Can anyone tell me what step number 2 is? Store 1, STO1. Or it could be anything 0 through 9, right? And then I'm going to, because I still got that number in my calculator, now all I need to do is say divide by. And then I'm going to hit the open parenthesis. And then I'm going to say 1 minus recall 1. Recall is RCL. 1 minus recall 1. And then I'm going to close parentheses, and then I'm going to say equal. If you don't say equal, it's not going to work. Good question. Other questions?
So just to follow that up, so make sure, because I've never used the store function before.
Oh, man.
So it's 0 through 9, you press store first, and then theoretically, I could store 9 things.
10, actually.
Or 10.
Yeah.
0 through 9 was 10. Okay.
Yeah.
But then you hit recall, not store again.
Yeah, to get it back,
Okay.
you hit
It's like-
recall. So you're think of it as putting the number in the drawer.
No,
So
this makes sense now. This is sick. I
cool.
should have known this since
I know. It'd make your life so much easier, wouldn't it? Yeah. Oh, yeah. Oh, hey, I'm going to show you some crazy stuff with this calculator.
I never taught that in jury.
You're going to, oh, well, it is drury. Yeah.
Once I store something, if I run out of 10 spots, let's just say, how do I get rid of it?
If you are up to that many spots, you are in a world of hurt. Yeah. Okay, so here's the trick. Anytime that I store something in a location, it blanks out what was there previously. So when you get up to 10, that means I've got 10 things going on right now. And at that point, I'm going to put you up for a PhD program, not an MBA program.
So you don't need a second equator every time.
No. I mean, you could, but you're just going to overwrite what's there, right? Yeah. Questions? Okay. Now, that's the formula for IGR. This is the formula for SGR. What's the only difference? Yeah, it's ROE instead of ROA. And if you remember back to an earlier conversation, we said that ROE is equal to ROA times the equity multiplier. And that equity multiplier is just 1 plus your debt to equity ratio. And so what we have here is as we get more and more debt in the capital structure, the equity multiplier goes up higher, 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 and ROE climbs away from ROA. And so you're going to see between sustainable growth rate and internal growth rate, if the capital structure is all equity, what's going to be the relationship between the two? Well, what's the debt to equity for an all equity firm? Oh, so you're jumping ahead. What's the debt to equity for an all equity firm? If it's all equity, how much debt is there? 0. What's 0 divided by anything? 0. So this term is just going to go to 1, right? So your equity multiplier is just going to be 1 for an all equity firm. At that point, your ROE is the same as your ROA. And so what's going to be the relationship between SGR and IGR? Oh, come on. Yeah, they're going to be the same, right? But as we add more and more debt to the capital structure, that SGR is going to climb away from the IGR in the similar manner to how ROE climbs away from ROA. Questions?
So for ROE, I know that like PM, profit margin times TAT times EM. So does that mean profit margin times TAT ROA?
Oh, very good. Check this out. He's thinking like a mathematician now. He says, wait a minute, if profit margin times total asset turnover times equity multiplier is equal to ROE, and we know that we could also say ROA times equity multiplier and get the same thing. That means ROA must be profit margin times total asset turnover. And he's absolutely right. I'll prove it to you. Net income over sales. Sales over total assets. What happens to sales? They cancel out, and what am I left with? Net income divided by total assets, which we also call ROA. Excellent point. Any questions? Okay, so what impacts IGR and SGR? Well, first of all, profit margin does both. Now notice that profit margin shows up in ROA. It also shows up in ROE. As the profit margin goes up, we have more profit and we can reinvest, and so that's going to cause those growth rates to both go up. Also, total asset turnover. As total asset turnover goes up, not only does it boost ROA, it also boosts ROE. So far, when we look at any kind of increase in those two, it's going to impact both. Also, something that impacts both is our dividend policy. What variable does our dividend policy impact? Does it impact ROE? Which one? Does it impact ROA? No, there are only 3 variables we've been talking about for the last 10 minutes. What are they? ROE, ROA, and what's that little b? Yeah, the plowback or retention ratio. The plowback or retention ratio. How do we figure out that plowback or retention ratio? It's 1 minus the dividend payout ratio. What decides our dividend payout ratio? Our dividend policy. So the higher the dividend that we pay out, the lower the retention ratio, the lower these growth rates are both going to be. Does that make sense? Okay. Now, finally, let's talk about the financial policy or the capital structure. The capital structure affects equity multiplier. The equity multiplier affects ROE, but does it affect ROA? Oh, come on. No, it doesn't. And so what we're going to see here is that our capital structure does not impact the internal growth rate, but it does impact the sustainable growth rate. Because remember, we are borrowing enough money to keep our capital structure the same. And so if our capital structure is 90% debt, that means for every dollar of addition to retained earnings, I can go out and borrow 9, right? I can grow a hell of a lot faster than if I were only at a debt-to-equity ratio of 1. So that capital structure policy is going to matter only for the change in the sustainable growth rate. Now, I do want to tell you one more thing to help you be able to remember why this is. Retention ratio makes sense because there's retained earnings on the top. Let me tell you why it's called plowback ratio. Anybody else here grow up on the farm? Okay, let me tell you what happens on the farm. Of course, there's a lot of things. Well, but here's what I'm trying to get to about plowing back. Whenever we would harvest the wheat or the corn, at the end of the season, there's a bunch of stuff left in the field. There's wheat stubble, there's corn stalks, and that stuff has nutritional value. And so what we would do is plow it back into the ground. Now, when I plow it back into the ground, that helps me in the next season to be able to grow more food. And the more stuff I was able to plow back into the ground, the better next year's crop would be. So that's why we call this the plowback ratio. What are we plowing back into the farm to prepare it for future growth? So that's why we call it the plowback ratio. Is it possible I will use either one of those words on the exam? Absolutely. Is it possible I will give you the dividend payout ratio? Absolutely. Is it possible that you will misinterpret the dividend payout ratio as the retention ratio? It's actually more than possible. It's entirely likely. That's one of the ways that I separate A's from B's is the ability to read. Questions? Okay. Forget that. Okay, so we have finished chapter 3 now. And now I want to make sure you've got your TIBA 2+ calculators out. If you don't already have them out, please get them out right now. And so for the next however many minutes here, I am going to walk you through chapter 4 and help you understand that you don't remember this material well enough, or that maybe there was stuff they didn't teach you at Drury that I can teach you here today. Did you get a scholarship to go to Drury?
I did actually.
Excellent. So Dr. Jones, our associate dean, he went to Drury on a choir scholarship.
Really?
Yeah, full ride for singing like a bird. It was great. Okay, so here we are in the chapter 4, and I'm skipping ahead a little bit here. Come on. In the first set of chapter 4 slides. And this is a very simple idea, but people screw it up all the time. And this is called the TVM timeline. What do you think TVM stands for? Time value of money. Now, there are two things on this line. There's present value and there's future value. Now, a lot of people think, well, wait a minute. Present value means something that's happening right now, And future value is something that's happening out in the future. And that is possible, but it's not the only scenario. In truth, all present value means is before future value, and all future value means is after present value. So I'll give you an example. Back in 1930, my grandmother sold some eggs, and she took the money and put it in the bank, and she left it there. And when she died in 2005, it had grown to $400,000. Let's say she put $1 in. I mean, this is a ridiculous example, but let's say she got $1 for the eggs back in 1930. She put that money in the bank, and then she forgot about it for 75 years. And then we're digging through her records when she dies 75 years later, and now it's worth $400,000. Now, that $400,000 was in 2005. Is that a present value or future value? It's a future value even though it happened in the past. And here's why. What's the present value in this story? Yeah, that dollar that she deposited back in 1930. Here's another one for you. My wife and I plan to retire. Let's say it's 2037. We plan to retire. And we plan to have $10 million in our retirement account. And that's going to provide us with our monthly payments, hopefully till we die, right? Now, in this story, that $10 million is happening in the year 2037, which is in the future. But for purposes of the TVM timeline, is that a present value or a future value? Yeah, it's a present value, and we're going to go beyond that. Okay, sounds like you guys have that one pretty well. If you don't have this formula on your note sheet, oh my goodness, it's just so sad. And if you're so bad at algebra, you should also write down this one, right? It's just divide both sides by 1 plus r to the t. That's it. Now, why do I tell you that? Sometimes questions will say, what happens to the present value if the required rate of return goes up? Now, instead of trying to remember, what I do is I write down this formula, and then I look at it, and I say, okay, that R's going up. That means we're dividing by a larger number. If I divide by a larger number, do I get something bigger or smaller? Yeah, I get something smaller. And so that's how I work with this. And you can do the same thing with T and with FV, and I always work that way. Now, the second thing I want to tell you is that these questions are always ceteris paribus. Which is fancy Latin talk for all else equal. And so I used to get so upset when I was teaching my China EMBA class. I would say, okay, what happens if R goes up? And they say, we don't know. And then we walk through how the bottom number gets bigger, so the thing gets smaller. They said, yeah, but you didn't tell us what happens to T in future value. Did I tell you they changed? No. You assume they stay the same unless I tell you they change. That's ceteris paribus. Does that make sense? So, ceteris paribus, the more I eat, the fatter I get, right? So what are we saying? I'm going to keep my same level of exercise, and I'm going to keep my same level of hydration. If I just eat more, I am going to gain weight. It just makes sense. That's how we discuss things, ceteris paribus. Okay, let's see what else we got here. Net present value. We like positive or negative? Positive. Simple interest. I keep earning the same amount of interest year after year. I do not earn interest on interest. But with compound interest, I do earn interest on interest. So let's say I earn 10% in the first year. At the end of that year, let's say I put $100 in. At the end of the year, I have $110. For year 2, my starting value is not 100. It is 110. And by the end of the year, I have 121, right? I have 121 by the end of the year. Now, if I look back and say, wow, I've made $21 over 2 years, is that actually more than 10%? Yeah, because I'm not only getting the interest on that original 100, now I'm getting the interest on the interest. Compound interest is your friend if you are collecting interest. It is your enemy if you're paying interest. Anybody here ever let a balance ride forward on your credit card? You guys aren't going to confess to it. Having to pay interest on credit card? It compounds, right? It just gets worse and worse and worse. I had a boss, he came to work one day, he looked terrible. I said, what happened? He said, I just figured out that my wife has been just paying the minimum amount on our credit cards. The minimum amount's like this much compared to the overall bill. It was even worse at that time. Now, what's the problem? Well, he's now paying interest on interest on interest on interest. By the way, what do you think happened to their marriage shortly thereafter? Yeah, they were done. Okay, questions? Before you agree to marry someone, should you look at their credit report? Absolutely. Credit report, STD panel, criminal records, right?
In that order?
You know, all of them. And if they fail on any of them, run. Okay, so let's talk about the idea of present value. Present value is the amount at this time zero, let's call it, that represents the value of all the future cash flows going forward, discounted at a rate appropriate to the risk of those cash flows. And so it's what we think of as the amount that we would be indifferent to receiving. Indifferent means you don't care. It's equally valuable to me to receive $100 today or $121 2 years from now at a rate of 10%. I am indifferent. Indifferent means you don't care. They're both equally valuable or equally appealing to you. We talk about discounting future cash flows. Why do we call it discounting? Because those cash flows the future values are going to be higher. But in order for us to figure out what they're worth today, they're not going to be worth as much because we've got inflation, impatience, all the I words that we think about. And so we know that the value today is going to be lower as long as interest rates are positive. Have we ever seen negative interest rates? Yeah, occasionally, for very short periods of time, we will see negative interest rates. How does that happen? It's when people get so scared of what's going on in the economy, instead of owning stock, they're going to sell all their stock and they're going to plow their money into these government-issued bonds and debt, stuff like that. And they're actually going to pay more for them than their face value. So they're actually knowingly going to lose money. Why? It's like paying an insurance premium to make sure your money is still there when the dust clears. But it's very rare. We saw it during the financial crisis back in 2008, 2009. Most of the time, though, for the purposes of this class, you can always assume required returns are positive. So you could write all these formulas down for this thing right here. This is a huge pain in the ass. Or you can use your financial calculator. What do you want to do? Something that's a huge pain in the ass or something that's relatively easy? Yeah, relatively easy. So that's what we're going to do. Okay, so here is our example. An investment of $100 provides a single payment of $133.10 3 years from now. What is the annual interest rate? By the way, interest rates, unless I tell you otherwise, are always annual. Interest rates, unless I tell you otherwise, are always annual. So here we go. We're going to use our time value of money keys on the calculator. Let's see, zoom out. Boom, there we go. Okay, now we are going to use this row of keys right here. It's the TVM keys. And the first thing I'm going to do is I'm going to hit second, clear TVM. Why? Because the calculator's like a wife. It never forgets. Right? I did stupid crap back in 1993, the first year we were married, right? And she still remembers. Now, gentlemen, this isn't saying anything negative about women. This is saying we need to stop doing stupid stuff, right? Okay, so the calculator's like a wife, never forgets. Fortunately, your calculator is superior to a wife in one way. You can clear it out, right? Second, clear TVM. Now, what in this problem is the present value? 100. And so I'm going to hit 100, and then I'm going to choose one of these 5 buttons to hit next. Which one do you think it is? PV. By the way, you put the number in first, then you hit the button. Okay, 3 years from now, which of the 5 buttons should I put the 3? Where should I stick it? N and T are the same thing. Okay, now what about the 10%? Oh, sorry, I'm giving away the answer. What about the $133.10? It's the future value, but here's something you need to understand. On the TIBA2 plus, cash flows in opposite directions get opposite signs. Let me say that one more time. On the TIBA2 plus, cash flows in opposite directions get opposite signs. And so I'm going to hit plus minus, turn that into a negative, and then I'm going to hit future value. Now, right? Oh, go ahead, ask it.
Does it matter if you do the present value or the future value in the negative?
And that is a lovely question. And you're absolutely right. It could go either way. Doesn't matter. As long as the cash flows in opposite directions. You might think it would take the interest rate and turn it negative, but it doesn't. Why? Because Texas. Right? Texas Instruments. Who knows? Interesting people in Texas. Okay, so now we have all of that information in there, and we want to compute the interest rate. What button should I hit? Compute. What does a compute button look like? CPT. You might have thought that was captain, but it's actually compute. And then we hit the button we want to compute. What are we trying to compute? I per Y. And it gives us 10%. Now, notice that little star up there? The star is your calculator telling you that this is a number that I calculated, not something that you put in. Now I'm going to share something with you. Probably didn't teach you this at Drury either. But if I wanted right now, I'm like, oh hell, what did I put in for future value? What I can do is hit recall future value. Boom, there it is. When's that going to be helpful? When you do something stupid. Let's do something stupid here. I'm going to change that to positive and hit future value. And now I'm going to compute I per Y. What does it say? So it says error 5. At least that's what I thought it was until I mentioned this to my colleagues. And they say, hey, dumbass, it's not 5, it's an S. It's error S for sign. I'm like, wow, I truly am a dumbass. Thank you for enlightening me. And I was telling this story a few years later, and I had a young lady from India in the back row who brought the manual with her, the calculator manual. And she goes, whoop, whoop, whoop. She's like, no, it is error 5. After class, I went and sent an email to my former colleagues. Who's the dumbass now? Okay, now why do I tell you that? Because when you see this, you're going to know that you've got this sign problem. Cash flows in opposite directions have opposite signs. If you get that squared away correctly, you will be in good shape. Okay, we're not going to go through that. In fact, we're going to skip over this stuff. We're going to talk about compounding within a period. Stated, quoted, and let's see, what else? Stated, quoted, and APR are all interest rates that do not include the impact of compounding. Oh, nominal. Nominal is the other word. So nominal, stated, quoted, and APR. Basically, all these things is the sub-period interest rate multiplied times the number of periods. So stated, quoted, nominal, APR, they are the sub-period interest rate multiplied by the number of sub-periods in a year. And so when I say 12% compounded monthly, that is a stated, nominal, quoted, or APR. What that really means is 1% per month multiplied by 12%, or by 12 months. So it gives us 12% per year. If I put $1 in there at time 0, am I just going to have $1.12 at the end? No, I'm going to have something more, because after that first month, what did they put in the bank for me? Little interest. And so I start earning interest on the original principal plus that interest. And it just keeps building on itself. And so the effective annual rate is the rate that gives us the same return as if there were no compounding within the year. So, for example, I could say 12% compounded monthly. I could figure out what's that going to be over the course of a year, and that amount would be our effective annual rate. And I will show you on your calculator the easiest way to take care of this stuff. We're going to say second, and the number 2. What does the number 2 say above it? Icon V, iconv, interest rate conversion. Interest rate conversion. We can convert from nominal to effective. We can convert from effective back to nominal. So let's take a look at this 12% compounded monthly. I'm going to put in 12, enter. That's the nominal, stated, quoted APR. I'm going to arrow up. How many compoundings per year for monthly compounding? 12, thank you for getting that right. By the way, how many weeks in a year? Whoa, you guys are on fire. Most common answer to that question, 54. Why? I have no idea. Arrow up. And now we're going to compute the effective rate. So what I'm really saying here is 1% per month is the same, and compounded over the year, is the same as 12.6825% compounded annually. So that it have no compoundings within the year. That's all we're really saying. If I put $100 in the account at 12% compounded monthly, at the end of the year, I would have $112.68. That's what that means. Is $12.68 more than $12? Yes. Where did the extra 68 cents come from? Compounding. Interest on interest. Okay, now let's try second. We're back here. We don't have to clear it out. We're just going to type in some new numbers. 7% compounded quarterly. So I'm going to put in the 7, enter, arrow up. Let's see for y. How many compoundings per year? 4. 4 quarters in a year. Most common wrong answer, 3. Why? I don't know. Oh, because it's 3 months, right? So what do I do now? Is that the right answer? No, what do I have to do? Yeah, CPT. Now, notice the star shows up. That lets you know that this is the latest calculated number. So what we're saying here is that 7.186% per year compounded annually is the same as 7% compounded quarterly. That's all we're saying. And so this ICONV allows you to go back and forth. I could put in, and it's going to be a little bit off, but I could put in right here 12.6825, enter, arrow down, arrow up. 12, we're compounding monthly, and then I could compute the nominal, and we're back at roughly that 12% that we started with. You can go either way. Now, could you put in the nominal and the effective and calculate C per Y? No, doesn't do that. Doesn't do that at all. You can do the effective annual rate using this fancy formula, but I don't recommend it. Now here's something I do want to point out. The more compoundings per year we do, the higher the effective annual rate. And so what we're going to see is this effective annual rate will start down here at 12%, but as we in one compounding, but as we compound it, it's going to get greater, but at a reduced rate. And eventually, it's basically going to top out. And so if we, well, it's not, oh, come on. Okay, so we keep adding the number of compoundings. In fact, let's go back to our calculator, and we'll put in 12 for nominal, enter, arrow up. We already have it up to 8 here. Let's do 365. What's magical about 365? Yeah, it's the days in a year. So this is daily compounding. I'm going to hit enter. I'm going to arrow up, and I'm going to compute. And now we're up to almost 12.75. The question is, how much higher can it go? Well, there are two ways we can do it. The first is my favorite, and that's just to fool the calculator. How do we fool the calculator? We put a boatload of 9s in here, and we hit enter, and we arrow up, and we hit compute. Notice it didn't change all that much. It's because this thing is, at this point, damn near asymptotic, which means that it gets close to that line, but it never quite reaches it. So, if I could actually do something called continuous compounding, every tiny little incident of time, I could compound again. Boop, 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 boop. It's not going to get me that much higher. In fact, let's store this number, store 1, and I'm going to look at this formula right here. If you've got continuous compounding, which means an infinite number of compoundings per period, all we have to do is take the exponential to that interest rate and subtract 1, multiplied by 100, and it gives us that amount. Now, not something you're going to have to do, but here we go. 0.12, and I'm going to hit second ln. What's above ln? Yeah, the exponential, right? And that's going to give me 1.1275. By the way, ignore the EFF. That's not actually there. It's because we were in this. So let's go ahead and say 12 second, oh, sorry, 0.12. 0.12 second ln, subtract 1, multiply by 100, equals. So that is the true mathematic number for continuous compounding. I'm going to subtract, recall 1, which is that number I came up with earlier, and I've got 4 times 10 to the negative 11th. For those of you who are not familiar with scientific notation, here's what that means. 0.000000000 4. That's it. So, faking out the calculator is going to get you close enough for anything that you're going to encounter in this world. Questions? Okay, now let's go to the special cash flow streams, the value of anything. So perpetuities are cash flows that go on forever and ever, and it's real easy to find the present value for those. It's just that amount of the periodic cash flow divided by the periodic interest rate. By the way, when you play with these things, if you're working with monthly cash flows, your interest rate needs to be in per month. If you're working with annual cash flows, your interest rate needs to be in per, annual, right? Okay. And so as long as we've got annual cash flows, we can use annual interest rate there. Now, I can also fool my calculator into doing a perpetuity using the time value of money keys. And instead of putting a regular number in for n, I just put a boatload of 9s and hit n, and it'll do the same thing. So I prefer the formula because it's so easy. We have growing perpetuities. Growing perpetuities, by the way, they start at time 1, and the present value that you get for them is at time 0. What if that cash flow started at time 7? The present value it would give you is at time 6. It always gives it to you one period in the past. And we have to name the cash flow this time because all the cash flows are different. Unlike before when we could just say C, now we have to say C1. What's the formula for a growing perpetuity? C1 divided by R minus G. Now, how can we fool your calculator? Well, remember the 9999999 trick? We're going to do that again, and then we're going to put R minus G in for I per Y. And that will give us the same result as using this formula. By the way, when you type interest into your time value of money, you always enter it as the percentage number. You're not going to hit the percent sign, but if it's 12%, you're going to say 12 I per Y. When you use the formula, would you do 12 or would you use 0.12? Yeah, 0.12. Always use decimals when you use formulas. Let's make sure you guys understand about how car payments work. You're going to borrow $60,000 for 5 years to purchase a BMW. The interest rate is 6%. How much are your monthly payments? Whenever you borrow money, the amount of money you borrow is the present value. Let me say that again. Whenever you borrow money, the amount of money you borrow is the present value. So we're going to get our calculator up here. And we're going to say second, clear TVM. What do I put in for PV? Yeah, 60,000 PV. The interest rate is 6%, but by the way, it's looking for monthly payments. We got 5 years. What should we put in for N? 60. Why 60? Yeah, it's 5 years times 12 months per year gives us 60 months. The interest rate is 6%. That's 6% per year. It's an APR. How do we figure out the monthly rate? Divide by 12. That's going to be our I per Y. So now we've got N, we've got I per Y, we've got present value. Now it's asking us to figure out the payment. What should I compute? PMT. And two things I want you to notice. First of all, the answer is $1,159.97. That's how much you're going to be paying every month. But the other thing I want you to notice is that negative sign. Does that mean BMW is going to be paying you? No, I wish. Right? So it's the cash flows in opposite directions have opposite signs. If I borrow $60,000, that's plus to me, right? But then every month after that, when I pay the money out, it's negative. Cash flows in opposite directions. Let's do something that's a little more difficult here. You've borrowed $300,000 over 30 years. What do you think you've bought, by the way? A house, right? And not even a very nice house anymore for $300,000, just sadly. Okay, it tells us what your payments are, and it asks what is the APR on the loan. What's the first thing we do? Yeah, second, clear TVM. I'm going to put in $300,000, and I'm going to put that in as PV, because that's the amount that we've borrowed. 30 years of monthly payments. How many payments are we looking at? What's 3 times 12? 360. Yeah, it's 360. And then the payments are 3085.84. But before I hit PMT, what should I do? Yeah, I got to hit the plus minus because cash flows in opposite directions have opposite signs. I'm going to hit payment. And then I am going to try to find the APR. What should I compute next? Yeah, compute I over Y. Now it's saying 1. Does that mean the APR is 1%? No, what is it?
You have to multiply by 12 to get that.
Absolutely. We've got to take that sub-period rate of 1% multiplied by the number of sub-periods in the year, 12, gives us 12%. And so you always have to remember when you're dealing with the periods and when you're dealing with interest rates that you got to fix those things. In fact, let's find the loan term. You've got 100,000 borrowed. What's the first thing I do?
Clear.
Yeah, second clear TVM. What do I put in at the 100,000? What is that? Present value. Very good. 10% interest. What do I put in for I per Y? Monthly payments. Oh, come on. Say again. Well, I got to divide by. Yeah, so I got to say 10 divide by 12. You got to say equal and then hit I per Y. Otherwise, he just puts 12 in if you don't hit equal. Okay, your payments are 1321.51. What do I need to do with that? Negative. Payment. And then I'm going to compute end. I've got 120 payments here. Is that 120 years? No, it's 120 months. How do I convert that to years? Yeah, you got to divide by 12. That's actually just 10 years. Annuities due. You guys need to practice that. Here's the secret. You should always do the annuity due first and then reset your calculator and do the ordinary annuity, because that way your calculator sets on the correct setting. So, example, I can say second payment and it says end. All cash flows in finance happen at the end of the period unless we are told otherwise. However, when we do annuities due, the payment happens at the beginning. How do I set this? Well, look at this. Over enter, you can see the word set. How do I get to that? Yeah, I'm going to hit second, I'm going to hit enter, and whoo! It changed to BGN. And I also want you to notice that it says BGN over here. If you're getting the wrong answers on the exam and they're off by a little bit, I want you to look up in the right-hand corner of your calculator and say, oh, shucks, I've got it set on BGN. I need to reset it to END. How do I do that? Same way. Second, PMT, second, enter. Sets it right back. My favorite way to test this is to ask you the difference between the present value of an ordinary annuity, which is where they happen at the end, and an annuity due, which is where the payments happen at the beginning. When you get that question, the first thing you need to understand is that the annuity due is always going to have a higher present value. Why? Because you get the money sooner, right? You're getting it one period sooner. As a result, the present value of that's going to be higher. Go ahead and figure out that present value first with your calculator set in BGN mode, and then just change the mode to END. All the numbers are going to be exactly the same as they were before. You just computed again, but now the present value is going to be a little lower because those payments are happening at the end of the period. Present value has to be lower. And by doing the ordinary annuity second, you now have your calculator set back to do all of your other calculations. You will not be hurting yourself for the rest of all time. Questions?
We need to put the future value, like for the products that we've done so far.
Do you need?
Future value 0.
Oh, if there isn't a cash flow out there at the end, we don't put anything. Yeah, when we get to bonds, there will be a cash flow at the end. And then things are going to get really hairy because you're going to have a present value, you're going to have payments, and you're going to have a future value. And now it really does matter about signs, right? The present value, we're going to make a big investment, and then we're going to get money back over the years, and then at the end, we're going to get a big amount of money. And so that second and third set of cash flows all have to have the same sign. The first one has to have the opposite. But don't worry about that for now. I will get you in chapter 5. Don't worry. Uneven cash flows. If you've never done this before, CF, second, clear work. We're going to make an initial investment of $10,000 at time 0. I'm going to hit negative, enter. We're going to try to figure out the present value of all these. Arrow down. I'm getting 2,500 at time 1, 2,500, enter. I've got to hit enter or it's like it never even happened. Then I'm going to arrow down. F01 is the number of times each cash flow happens. How many times do I get 2,500 in a row? Twice. 2, enter, arrow down. Now, at this point, you're freaking out. It's saying C02. You're like, wait a minute, cash flow at time 2 is 2,500. Wrong. The calculator doesn't count that way. So you are now, C02 is 0. I'm going to hit 0. I'm going to hit enter. I'm going to arrow down. How many 0 cash flows do we have? 1. I just leave it as is. Arrow down. And then the last cash flow is 7,500. Got to hit enter. Now, I'm paranoid. I like to go back and check my work. Make sure that all that stuff got in there because sometimes I forget to hit the enter key. Now, if I want to find the present value for these, here's what I do. I hit NPV, and then I put in this required return 7% for I7, enter, and then look up here. It's telling us, look, you can go up or down. So I'm going to go down. It gives me NPV here. It says 0. Do you think that's the correct answer? No. I got to hit compute. And the correct answer is $241.76. The net present value of that set of cash flows is $241.76.
On the F, we put 2 for steps 1 and 2. Does it change if we just leave it 1 and put it in twice?
Okay, students always want to do this. Well, it's like, well, can't I just put all? Yeah, you can. But then I'm going to give you a mortgage problem where you're going to have 30 payments of this and 1 payment of that, and you're not going to want to type that in 29 times, right? You'd rather just put in 30 or 29 or, you get where I'm going?
So it doesn't make a difference, but there might be a case where it's inconvenient.
Yeah, it's inconvenient, and the more times you have to enter it, what's more likely to happen? Yeah, mistakes. Yeah, go ahead, learn it the hard way. But you're right, the math works out. If you do it right, the math works out. Now, here's the other thing you need to know about the NPV key. All it's really doing is adding together all the present values of those cash flows. You're going to have one problem where it says you can afford $1,200 payments per month for 3 years, and then you can do $1,500 for 2 years, and these are monthly payments. Use the CF keys. Put in $1,500 for, if that's what I said, $1,500 for C01. By the way, CF0 is 0. And then you put in for F01, if it's 3 years of monthly payments, what's that going to be? 36. And then you've got your $2,500 for C02. And that's going to happen for 2 years. What is F then? 24. You're going to enter that. And then you're going to, and the question is, how much are they willing to loan you? You're just going to go hit that NPV button. You're going to put in the interest rate. By the way, it's an APR. You got to divide by 12. And then you're going to compute the NPV, which is just the present value of those 2 cash flows that you threw out there. And remember, the amount you borrow is always the what? Present value. And so when I ask you how much are they willing to loan you, the answer is always the present value. Have I proven to you that you don't know enough about Chapter 4? Yeah. Jump on that practice, beat the snot out of it. As you have questions, let me know. You can even bring questions to our next session when we're going to do the exam calculation practice review. Questions? Okay, see you next time.